Okay, Algebra 2. This is day 2 notes on Unit 2. It's all about functions. Unit 2, day 2 is function notation. You can read through some of this. All right, functions, they convert inputs to outputs. Hopefully you're familiar with this from Algebra 1. If not, this makes sense here a little bit, hopefully. Some notation stuff, all right? Some people still confuse this with different things, so be careful. Some examples. It says evaluate each of the following functions. All right, everything has a name. F of x, g of x, h of x are just function names. All right, lots of notation. Get used to it. The first one, A, is f of x equals 5x minus 2. This means f of 3. So find the value of the function when x is 3 is what that means. So all you're going to do is plug in 3. All right, everywhere you see an x. So it's just 5 times 3 minus 2. All right, simplify that. 15 minus 2 is 13. So f of 3 is 13. All right, f of negative 2, same idea, just plug in a different value. All right, so 5 times negative 2, negative 10 minus 2 will be negative 12. All right, you can do the next, try those on your own, B and C. The next thing down, all right, sometimes it's confused with multiplication. All right, depends on how familiar you are with this, I guess. All right, so y is f of x. This doesn't mean like f times 3. This just means plug a 3 in. All right, so be careful. Y equals f of x. Some people still forget that. All right, they're the same thing. You're going to see f of x a lot more, or g of x, whatever letter they give it. It's just a name, all right, instead of y, same idea. All right, functions come in different types, which is an equation. All right, you're going to see in a minute a graph and also a table. I'm reading right off the notes here. Hopefully they have this. If not, check it out. Let's try number 2. All right, water is boiling at 212 degrees. It's cooling down to a 65-degree room. Here's the temperatures after each hour. This is just like a table on your calculator, right? It's like an XY table on your calculator, same thing. All right, they got fancy letters for it though. T of H is the temperature after so many hours. All right, so find T of 2. What is the temperature after 2 hours? Well, if you have the chart or the table in this case, you don't have to do any work. You're just gonna look at it. Temperature after 2 hours is 104 degrees. All right, so if you have the table, no work necessary basically. T of 6, what's the temperature at 6 hours? I got 68. All right, nothing I've really seen before. The letter B starts getting a little bit different though. Some of you get caught up on this notation. All right, so T of H equals 76. This means the temperature at which hour is at 76 degrees. So you're trying to find the hours this time, the number of hours for it to reach 76 degrees. So look across your Y's. 76 is here. That's at hour 4. So when H equals 4. All right, again, just notation, getting used to it. All right, going to get caught up in all these letters and stuff. The next page, we have a function, but now we actually have the picture. We have the graph. They didn't label much, so you got a graph of something going on here. And it just says it's y equals f of x. Okay, so there's your function. And now evaluate f of negative 1. So f of negative 1, some people know this, some people don't. You might want to jot it down. F of negative 1 means what is the height of the graph at negative 1. All right, so if you need to, jot that down. What is the height? Oh, can't read this. All right, so what is the height of the function or of the graph at x equals negative 1? That's what this means, essentially. Most of you know that already. If not, jot it down. All right, so f of negative 1. Again, not much work. Just gotta look at the picture. All right, look at the picture, see what's going on. So try to find your x and y axes. This one's not labeled very well. There's the origin right there. So at negative 1 on the x-axis is here. What's the height? Well, it's 0. So f of negative 1 is 0. F of 1. What is the height of the graph at 1? So at 1 on the x-axis, what is the height here? Up 4. So height is 4. All right, try f of 5. Not too bad. Count that out. The part B says evaluate f of 0. So what is the height when x equals 0? Looks like 3. All right. What's special featured? Does f of 0 always correspond to? What did we just find? When x equals 0, the height was 3. When x is 0, you're actually finding the y-intercept. All right, so y-intercept is f of 0 every time. Short notes today. So letter C. What values of x solve the equation f of x equals 0? So where is the height 0 is what this means. Right? Write that down if you're not sure about that. But where is the height 0? So let's find that first. Where is the height 0? Well, the height is 0 at -1. We already found that one. Also here and here. So when x equals -1, looks like when x equals 3 and 7. So that's where the height is 0. What special feature is that? Those are x-intercepts. All right, x-intercepts. You've heard the word roots before, zeros, all those things mean the same, all right? Letter D, not really an important question. Where is the height equal to 3? What two consecutive integers is the largest solution? So I'm trying to make you think. Where's the height 3, first of all? Maybe you want to draw a line in. Well, the height is 3 anywhere across this line. So where's one is the largest? So looking for the biggest one. I got one over here. So it's between these two numbers. What's that, 7 and 8? So between x equals 7 and x equals 8. Not really an important question. Number 4 is the better question. Number 4, all right, for a function y equals g of x, it is known that g of -2 equals 7. Which of the following points is on the graph of g of x? So g of -2 equals 7. All right, so hopefully you're getting familiar with this. This is an input, this is an output. All right, g of -2. So if that's an input, it's an x coordinate. If it's an output, it's a y coordinate. All right, so instead of just giving you the point, they're trying to make it look fancy. All right, it's function notation, get used to it. The point -2, 7 is on this graph. It's choice 2. Not much work. All right, as long as you know the notation, you'll be fine. The last one, trying to get you to use your calculator. We'll see how it goes. Physics student drops a ball, 50-foot high building, models this equation. Use the table to determine the 10th of a second when the ball hits the ground. We'll do this one in class probably, but you can draft this in your calculator. Hopefully some of you have seen this equation. I'm going to zoom in so you can see it. 15 minus 16t squared. All right, it's going to be a parabola. It's got a negative sign in front of the t squared, so it's going to be upside down parabola. So let me want to draw a picture. Here's a rough picture, all right? You drop a ball, and it's going to fall and hit the ground. All right, this 50 is actually how high they are. They're 50 feet off the ground. All right, so how is that in the question? All right, so finding there's 10th of a second when the ball hits the ground. So down here is like your time that's passing. If you can find that, that's good. All right, it's all calculator. I'll show you doing the calculator. We'll do the work for it too eventually, but not yet. All right, give it a shot. We'll finish that one later. Short notes today. Homework is on the next page. All right, day 2 homework.